Hello, good evening once again, guys. All right, so we are onto this YouTube session. It's a free live session, and what are we doing over here? We are going to do the practice on reaction mechanism. Let's wait for your friends to join in. Okay. Yes. Welcome, guys. Welcome. Good evening, all of you, once again. All right. So just before this, we had a free session on Unacademy, the special class basically, and we had discussed the SNAR mechanism, benzyne mechanism. We are going to continue doing that. All right. So yes, if you want to find me on Unacademy, you can follow my profile, Jagriti Sharma. You can search over here in the CSIR net category, and you can follow me for all the important courses and free classes also. So as you can see over here, these are the plus courses. Basically, plus is a paid platform. What is going on right now? We have completed the reactive intermediates in the month of April. We are also doing detailed inorganic chemistry. We have already completed chemical bonding. We have coordination chemistry is going on in the month of May. We are going to start organometallic chemistry and pericyclic and photochemistry in the organic. Right. So what you can do is, if you want, you can join an Academy Plus using the code Jagriti S Live. Okay, that gives you a 10% discount. Right, many offers are going on. I'll soon inform you if there is any good offer in which you can subscribe, right? Okay, so special classes for the month of April, organic reaction mechanism we are doing, complete reaction mechanism. Special classes for the month of May will be on complete stereochemistry and complete heterocyclic chemistry. Alright, you're going to get the schedule very soon. Alright, I'll be creating these classes very soon. You're going to get the schedule, and YouTube sessions will be practiced on these topics. So don't, guys, please follow all these classes. Free content, you're getting a lot of free content, concept and practice. So yes, pay attention and come to the classes. All right. So practice on reaction mechanism part 5 is what is going on today. Friday and Sunday 6 p.m. is our timing for YouTube. Okay. Low voice hai. Anusha, increase the voice. This is the maximum I can speak. All right. अब ठीक है? Now it's okay, right? Yes, chalo, let's do our first question for today. See, usually we do 7 and 8 questions. All right. So let's see. We are doing the first question today. What is the major product once again? NaNO2 and HCl combination 0 to 5 degree centigrade. What is your major product? Let me write the options. Yes. So what would be the correct answer for this question? Yes. All right. Answer is option number D. Okay, very well. Okay, why is that so? So first of all, it's getting converted into the diazonium. Yes or no? In the presence of NaNO2, this molecule is getting converted into diazonium salt like this. N2 plus Cl minus. Yes? Very good. This is Demjanov reaction. Very good, Ankit. Okay. So see, it is going to give you a carbocation, right? And the carbocation is going to rearrange. All right. So this is, let's say, this is your carbocation from over here. This carbocation is going to rearrange. One of the bond is going to open up like this. Let's say this is it. And let's say since this carbon carbon bond has opened up, so you get a positive charge over here, and then water is going to attack, give you option number D. So even if let's say you don't know that this is a name reaction, this is a name reaction, Demjanov rearrangement. Yes, isn't it? Yes, this is your Demjanov rearrangement. So if you remember the name reaction, it's really good. If you don't remember the name reaction, you can just simply do it through the formation of a carbocation rearrangement and finally the attack of water. Okay, Demjanov rearrangement through the carbocation formation. Good evening guys who are joining. Welcome. Let's do our question number 2. Okay, once again, same type of question. The major product, the major product formed in the following reaction is, in the following reaction is, you have one hydrogen above and the deuterium is below. H2O2 and heat. Let me write the options. All right. So what do you do over here? See, these two bonds are above the plane, isn't it? Yes. What is this reaction, guys? Thin pyrolytic elimination. Very good, Shoaib. So there's this hydrogen above, the deuterium is below. Selenium SEPH group, this is going to get oxidized. Let's say I am writing O minus and Se plus. You can write in this way, that will also be correct, or you can also write it like this. This is also correct. Both of these representations are correct. Yes. So it is going to be your syn elimination reaction. You are going to remove the proton, not the deuterium. So that is why the hydrogen is eliminated along with the OSEPH. What is going to be the product? Product is option number C. All right, the pH groups are trans to each other. They are already in the perfect conformation. Why? The bulky phenyl groups, they are trans to each other, and the hydrogen, which is a easily removable group, that is also on the same side as the selenium. That is why you get this major product along with PHSeOH. Okay, so answer is option number C. Yes, very good, very simple. Now see guys, today only we have discussed this one thing. Let's do this question. Today only in the special class we have done this. The correct order of reactivity of the correct order of reactivity of para halo nitrobenzene in the following reaction is in the following reaction is. So you have this reaction given over here. You are having a para halo nitromolecule, and this is your NaOMe over here, and the product is also given. Methoxy group added over here on the para position, replacing the X group. Now in the X group you have all the halogens. So option number A is, alright, X is all the halogens. Okay, so which reaction, what is going to be the order of reaction? Okay, so let's say your para chloronitrobenzene is going to react better than para iodonitrobenzene, then para fluoronitrobenzene, and para bromonitrobenzene. This is option number first. Para fluoronitrobenzene, para chloronitrobenzene, para bromonitrobenzene, and para iodonitrobenzene. Same option number C, the iodonitrobenzene is going to react better, then bromo, then chloro, then fluoro. Option number D, bromo better than fluoro, then iodo, and then chloro. Yes, today only we have discussed this, guys. Yes, what do you say? All right, very well. Answer is option number B. Today only we have discussed this, that when the fluoride is there, right? When you are doing the SNAR mechanism, guys, when you are doing the SNAR mechanism, what happens is the fluoride is going to drive the reaction forward better than the chloride, bromide, and iodide because of the electron withdrawing property. The first step, which is the nucleophilic attack on this carbon, this is the rate determining step, and this requires this carbon to be as electrophilic as possible. Yes, isn't it? And that is done by a more electronegative fluorine. And the order is going to be equal to the electronegativity order. This is going to be your rate of reaction. Today itself, we have discussed this in the special class just before this class. Please watch if you already haven't. Chalo, let's do next question. Question number 4 is correct order of solvolysis. See, actually, I have already made you do this question, so it's kind of a revision so that you don't forget. Okay. GP. And that is what we are always looking for. If a reaction has NGP, it will be the fastest reaction. Option number 3, it has an option of NGP because now by NGP you are forming a 5-membered ring. 1, 2, 3, 4, 5 on this side and 5 on this side. So it's forming a 5-membered ring. That is why it is going to be faster. Alright, what about option number 2? If you are doing NGP over here, it's going to give you a hindered 4-membered ring, isn't it? It is going to give you a hindered 4-membered ring, which is causing a ring strain. That is why no NGP for this molecule. No NGP for this molecule because it is hindered, right? So if it is not going through NGP, or even if it is going through NGP, it is a strained molecule and hence it is going to become a slower reaction as compared to your simple substitution. Right? So 3 is going to be fastest as compared to 1 as compared to 2 over here. So C is your correct answer because of strain. Absolutely. Yes. Question number 5. Another easy question. Questions are always easy. It's just that we need to be practiced enough. Another very easy question. You are getting excess of AlCl3. What is the major product? Okay, this is your anhydride molecule, toluene molecule, excess of AlCl3. What is the major product? Let's see. Let's write the options. यस विष्णु, क्वेश्चन की कोई गलती नहीं है, क्वेश्चन तो इजी होते हैं. ओके चलो, लेट्स प्रूव इट करेक्ट कि क्वेश्चन भी इजी होते हैं. Okay. Yes. So the correct answer will be yes. So it's for this question, it's going to be option number C, and it's not going to be option number D or option number A. These are both wrong. Yes. Why? Because when you are once doing the Friedel-Crafts acylation, let's say you are doing the Friedel-Crafts acylation and you are making this acyl anion as well as the carboxylate ion over here, what happens is definitely the molecule is going to attack from the para position over to this carbon. Okay? Yes, and after that, what happens? Molecule attacks either from ortho or from para, but major product is going to be obtained from the para attack. OAlCl3. Okay? Now, one of the proton is going to fall off and it's going to give you this kind of a molecule. However, you have the carboxylate over here. What is the problem? The problem is you have a carboxylate salt connected with AlCl3. Okay, like this. You don't have any leaving group. O minus is not a leaving group. So that is why the ring cannot attack onto this carbonyl and remove the O minus. O minus is not removable, right? That is why you are getting option number C as your major product. However, if I add, let's say, into this mechanism, if I add one more step, if I added one more step into this mechanism, I have this methyl. I am adding PPA, polyphosphoric acid. What is going to happen if I provide acid, if I provide enough acid to protonate this oxygen good enough so that it leaves, then I might get this product polyphosphoric acid. Yes or no? I might get this product. So, acid is what is required to protonate this oxygen and make it a good leaving group. Other than that, if I don't have, yes, if I don't have acid, only excess of AlCl3, it doesn't matter how much excess you have because the reaction is going to stop over here. O minus is not a good leaving group. Yes. Alright, so for those who have not yet seen the reaction mechanism free classes, please do on Unacademy. They are all free, guys. You just have to use the code Jagriti to unlock. So, Okay. Okay, guys. But I see that not everyone is replying in the live chat, guys. Everyone try to answer. Definitely the answer is correct. Answer is option number B. What we are doing over here is NGP by a carbon-carbon double bond, isn't it? NGP by a carbon-carbon double bond. And because of that, we are going to have retention, isn't it? This reaction is acetylysis. OTS is going to get eliminated and we are having retention because of NGP. Inversion twice gives you retention. So we are just directly going to say that acetate group is going to be added on the same side as the OTS group. Yes, once you identify the NGP reaction, you are directly going to write the retention product. Okay. Yes. Hello, Shubhankar. I'm good. Thank you. All right. Let's do question number 7, guys. Easy question once again. Once again, guys, what is going to be the major product of this question, of this reaction? Okay. So you have this molecule, four-membered lactone system, 82AlCl, that is your Lewis acid. What is going to be the major product? Options are like this. CCl3 is going above. All right. Everyone has tried. Yes, guys, what's going to be your major product? Benzene is a nucleophile. Sometimes, when you don't have any other possibility, I'd shown you one more example on this. Okay, so let's see what is happening. What is your correct answer, guys? Anyone? Only three answers. B is your correct answer, by the way. So what is happening in the presence of this Lewis acid? What is happening, guys? What does this Lewis acid do? It's going to help this bond in breaking. As always, you are generating acylium cation. This is O minus. So AlClEt2 goes with the O minus, your CCl3. So basically what just happened, guys, this is your simple reaction in the presence of a Lewis acid. The O minus, this bond, the ester bond is going to open up, and the Lewis acid goes with the O minus. It is a Lewis acid, so definitely it's going to go with the O minus, isn't it? Yes, isn't it easy to understand? Very simple. Lewis acid is electron deficient, no? So it has to go with the O minus like this. Alright, now who is a nucleophile? You have benzene. Benzene could act as a nucleophile like this. And what do you have? You can just write as it is. This is your pH molecule. Obviously, it is going to lose a proton. Your simple electrophilic aromatic substitution, acylation. This is O minus connected with AlClEt2 and CCl3 as it is. Now, after the aqueous workup, which is actually not mentioned in the question, but you always end up with a aqueous workup in these kind of examples. Answer is option number B, right? Why the CCl3 is still below the plane? Because there is no inversion on this carbon. There is no reaction on this carbon, isn't it? The reaction is on this carbon over here, the carbonyl carbon. Yes. So that is why there is no inversion on this carbon. It will be as it is, and your answer is option number B. Let's do a similar question. Question number 8. Once again asking you what is the major product of this reaction. Okay, let me just write once again. Okay. What according to you is the major product of this reaction? Okay, all right. So another example where your chlorobenzene works as a nucleophile, right? So your answer is option number A. And what is happening with this reaction? What is involved over here in the presence of Ag plus BF4 minus? What do you have? What is the Ag plus going to do? Ag plus is going to remove the Cl over here. Yes. If the Cl minus is removed, guys, what do you have? A Cl minus is removed. So you will have AgCl. Yes. Along with that, you will have CO2 molecule. Along with that, you will have a carbocation on the bridgehead position. And I always say कि bridgehead position carbocation is not stable, right? But still we are doing a mechanism जिसमें कि bridgehead position पे carbocation है. How is that possible? So BF4 minus can break down into BF3 molecule and a F minus. This is a source of F minus, isn't it? Yes. All right. So over here, the F minus could attack. However, you have a solvent in excess. This is your solvent which is given over here. And I have not given you, by the way, I have not given you any option in which the fluorine is directly attacking. So ये option हो गया cancel. And there is a solvent in excess. What is the solvent? You have chlorobenzene. So chlorobenzene is going to attack over this carbocation and going to give you the product like this. Now why have I written the Cl into the ring? Why have I written the Cl into the ring over here? Because it is not specific that the Cl is going to be ortho, meta or para. You don't have to be worried about that. You will get a mixture of products. Okay. But yes, this is how the substitution takes place. Okay, the solvent chlorobenzene also works as a nucleophile in this reaction. Two examples, if you want, you can just star mark both of these. कि भाई benzene जो है solvent है, it is working as a nucleophile. Over here, just star mark both of these examples if you have noted them down. ठीक है? Yes, let's do one more question. Question number 9. All right, I have to erase this one. Okay, once again, the major product which is formed in this reaction is KOH. First step में KOH and ETOH मतलब alcoholic KOH you are having. Second step में you are going to have alpha beta unsaturated ketone molecule. Third step you are having HCl. What is your major product? Option number A goes like this. All right. Yes, Vishnu, very good. One more reaction followed by that. Try this out, guys. It's a very nice question. Yes, Vishnu, still one more reaction. And Robinson annulation is basically Aldol and Michael combined. So, what is the reaction after Robinson? Yes, Ankit. Also, yes, guys. So, we are also having this three-membered ring fragmentation, isn't it? Three-membered ring fragmentation. So, yes, which side in the presence of this alcoholic KOH, there's only one proton which is present. So, let's say you are doing the enolization from here. This is your methyl group, and you are doing, this is one more methyl. You are doing conjugate addition from over here, isn't it? Yes. So you are doing conjugate addition from this side. You will get one methyl and one more methyl over here. Okay. So you still have base in the medium. What will happen, guys? This methyl could do enolization once again, and it could attack over this carbonyl. So 1, 2, 3, 4, 5, and 6. A six-membered ring will be formed. Let's say after one more. See, this is your Michael addition. After the Michael addition, you can cause this intramolecular aldol reaction. Okay. So after the intramolecular aldol reaction, let's say you are going to have this carbonyl over here, the OH on the junction, the methyl on the junction of two rings, and this is what you have, this molecule. And through the E1CB elimination, and since you don't have E1CB, you have HCl. All right. So in the presence of HCl, you can just have your E1 elimination, right? Or E2 elimination. So through this mechanism, you are first going to generate a carbocation over here. In the presence of acid, you can have a carbocation over here, and then this followed by that, this proton could be lost, isn't it? Yes. So carbocation in the presence of acid, the proton could be lost. You can directly write a double bond over here, but what's happening with this three-membered ring? What is happening with the three-membered ring? So let's say we are not making this proton eliminate first. Let's say what we are doing is, let's say this carbon-carbon bond breaks down. And you get a positive charge over here and one double bond over here. Okay? Yes. So this is what you have. In the presence of HCl, you have a Cl minus free which could attack. And also, In the presence of acid, you will get isomerization of the beta gamma unsaturated ketone to your alpha beta unsaturated ketone system. Whenever you have beta gamma unsaturated ketone and you have acid, it is going to isomerize like this by the removal of this proton over here. Yes, so you had the fragmentation of this three-membered ring. You also had the isomerization to give you option number B. Yes, so this is your final product, option number B. Okay. All right, guys, we have done 9 very good questions today. More practice sessions are coming up. The next session will be on Sunday, as you all already know. And there's one last thing I want to tell all of you, that if you are interested in joining an Academy Plus, where we are doing a lot of courses, and if you are joining through my code, let's say if you are joining an Academy Plus using Jagriti S Live, it is not that you are getting only my classes, you are getting classes of all the educators. Unlimited access means you're getting the classes of all the educators under CSIR net category. Okay, so along with the doubt clearing session, weekly test and structured courses. All right, and if you are joining Iconic, you are getting personal guidance also, and expert guidelines, test analysis, and study planner. So this is what you're getting extra in the Iconic subscription. All right. If you want to join an Academy Iconic, you have to select Iconic from over here, or you have to select from over here on the Unacademy app, and you just have to apply a code, that is your Jagriti S Live. Alright, that code is going to fetch you a 10% discount. Alright, and yes, guys, if you are liking this session, then you can subscribe to the channel and also press the bell icon, because then only you'll be getting notified about my classes, and also join the Telegram group. All right, that group is you're going to get all the links in the group, as well as the assignments to practice from. Okay, so yes, take care of yourselves. I'll see you in another such session. Bye everyone, have a nice evening.